this lesson, we're going to talk about the properties of logarithms. So for positive numbers b, m, and n, where b does not equal 1, the following properties hold. So you have your product property, which states if you're taking the log of two things that you are multiplying, you can separate those into log base b of the first thing plus log base b of the second thing. Then you have your quotient property, which is the same exact thing as the product, except instead of multiplying, you're dividing, and you would do the log base b of the top and use a minus sign, and then log base b of the bottom. And then you have your power property, which states if you're taking the log of something that has an exponent, you can pull that exponent to the front and have that times the log base b of what you had. So we're going to practice expanding these and condensing them. So we're kind of taking them together, or we're taking them apart or putting them together. All right, so I see that I'm taking the log of two things that I'm multiplying. So when I'm multiplying, I can take and add two logs. So we have a log with a base of 3 of the first term, and then plus, and then a log with a base of 3 of the second term. But I don't want to leave those exponents in that spot, so I'm going to use that power property that says I can take those and move them to the front of their respective logs. So this would be 2 log base 3 of A plus 7 log base 3 of B. And now I'm expanded fully. So on number 2, I'm taking the log of two things I'm dividing. So I will do the natural log of the top number. And since I'm dividing, I'll have a minus. And then natural log of the bottom number. All right, if you look at number 3, you have two things on top that you're multiplying, and then you're also dividing by something. So let's start with the dividing part. So we have log base 7 of the top, which would be r to the third, t to the fourth, minus, and then log base 7 of the bottom. Now within that top part, we have two things that we're multiplying, so we're going to split those. So we have log base 7 of r to the third plus log base 7 of t to the fourth minus, and then we have that log base 7 of v. Now, again, I'm not fully expanded because I still have those exponents left, so we're going to pull those to the front. So we have 3 log base 7 of r plus 4 log base 7 of t minus log base 7 of v. All right, another division one. So we have natural log of the top minus natural log of the bottom. No powers to move on that one. All right, on number 5, we have the natural log of 2 times x to the 5th. So I have natural log of 2 and then plus natural log of x to the 5th. We're not going to leave that power there though, so we're going to pull it to the front. So we have natural log of 2 plus 5 natural log of x. Number 6, we have 3 things that we're multiplying, and you can kill 2 birds with 1 stone here. If you already realized that those powers are going to move to the front when you separate these and do like your log base 6 of 2 and then plus. This will be log base 6 of m to the 5th, so you already know that 5 is going to move to the front of the log, so you can just say 5 log base 6 of m plus, and then again, you know that 3 is going to move to the front of the log, so 3 log base 6 of n. If you need to go ahead, though, and write it in the exponent and then move it, that's perfectly fine. All right, so now we're going to write these as a single logarithm, which means we're going to condense them. So if you have a number in front of your log, you need to go ahead and move that up to the exponent of your log. All right, so now we have log base 4 of m to the 4th plus log base 4 of n to the 3rd minus log base 4 of p. Now notice all of these have the same log. In order to put two logs together, they have to have the same base. They all have the same base. So we are adding these first two, so that means we should combine them into one log with a base of 4 where we multiply the parts. So this would be m to the 4th times n to the 3rd. And then we have minus log base 4 of p. All right, so now I'm subtracting two logs, which means I should divide their parts. So this will be log base 4 of m to the 4th, n to the 3rd will go on top, and p will go on the bottom. So I'm going to go ahead and move this up here. Now 2 to the 3rd, that is the same thing as 8. So I'm going to go ahead and put that on there. And this will be 5 to the 2nd, so that'd be natural log of 25. Since I'm subtracting, I can make this into one natural log with the first part on top and the second part on the bottom. All right, number 9, I'm going to move that number up to the exponent. So we have log base 2 of c to the 5th, and this would be log base 2 of n to the 7th. I am subtracting those two logs, so to combine them, I will divide their parts. So this is log base 2 of c to the 5th divided by n to the 7th. All right, same thing here. I'm going to move this 2 up here, so now we have natural log of 49 plus the natural log of 2. Since I'm adding, I will multiply parts, so I need to multiply the 49 and the 2. So this will be natural log of 49 times 2, which is 98. All right, number 11. This time I have a fractional number in front. And if you'll recall, when you have a fractional number, that means you have a root. So this is a cubed root. So this is the same thing as saying the natural log of the cubed root of 27. And this is the natural log of 2y to the 3rd. So 2 to the 3rd is 8. And then you still have to take the y to the 3rd. So you're going to simplify along the way if you can. So the cubed root of 27 is 3. So I have natural log of 3 minus natural log of 8y to the 3rd. So since I'm subtracting, I will divide their parts. So natural log of 3 on top and 8y to the 3rd on bottom. When you're expanding these, instead of putting them back together, make sure you write your roots as a fractional exponent before you start moving things around. So if you're given the cubed root of 27, you would write 27 to the 1/3. All right, so I move the 2 up here. That gives me log of 100. Plus, I'm going to move the 4 up here. So I have to take 3 to the 4th, which is 81. And x to the 4th as well. Since I'm adding two logs, I need to multiply their parts. So 100 times 81x to the 4th would be 8100 x to the 4th. All right, the pH of a solution is a measure of its concentration of hydrogen ions. This concentration that's measured in moles per liter is written H plus and is given by this formula. What is the concentration of hydrogen ions in acid rainfall? So if you look at acid rain, the pH is 4.5. So in order to solve for H plus, we have to be able to plug in for the pH. So the pH is 4.5. So 4.5 is equal to log of 1 over H plus. So I am dividing two things, which means I can split this into two logs and do log of the top minus log of the bottom. Now, log of 1 is 0. So now I have 4.5 is equal to a negative log of H plus. I'm going to divide by that negative. So if I divide by negative, I get a negative 4.5 is equal to log of H plus. Now, in order to get rid of this log with a base of 10, I need to take 10 and raise it to both sides. That's going to cancel. So my h plus is equal to 10 to the negative 4.5, which is about 0.0000316, not 3, 316.